Welcome back to the AI Research Roundup. I'm your host, Alex, and today is June 16th, 2025. We're looking at a paper that hit Hugging Face's trending list just a few days ago, titled Seedance 1.0, Exploring the Boundaries of Video Generation Models. This paper introduces a new video model designed to overcome the classic challenge of balancing prompt accuracy, motion quality, and visual detail. It uses an efficient architecture with a diffusion transformer, which is the core engine that generates video from noise, and is fine-tuned using reinforcement learning from human feedback, a technique that uses human preferences to improve the model's output. Building on those techniques, the first figure gives us a great visual summary of the results. We see two radar charts here, which are great for comparing multiple models across several criteria at once. The chart on the left evaluates text-to-video generation, that's creating video from a text prompt. And the one on the right is for image-to-video, where you animate a starting image. In both charts, the green line representing Seedance 1.0 clearly outperforms competitors across most metrics, including speed, aesthetics, and an overall ELO score, which is a rating that measures user preference. Alright, so how does Seedance achieve those impressive results? This next diagram shows us the model's architecture. On the left, we see video frames are first compressed by a variational autoencoder, or VAE, which is a component that makes the video data much easier for the model to process. This compressed data, along with detailed text captions, then enters the core engine. This engine uses separate blocks to process spatial information, so what's in each frame, and temporal information, meaning how things move over time. This separation is key to balancing visual quality with believable motion. Of course, a sophisticated architecture like that needs incredibly high-quality data to learn from, and this diagram shows exactly how they prepare it. This is their multi-stage data processing pipeline. It starts by gathering raw video from diverse sources. Then, the crucial curation step begins. They use temporal segmentation, which is basically just cutting long videos into shorter clips, and semantic deduplication to remove near-identical content. This process ensures the model learns from a wide variety of unique examples. Finally, the cleaned clips are encoded using that variational autoencoder and paired with detailed text captions for training. So once that high-quality data is ready, this next diagram shows us how it's used in the model's training and inference pipeline. The top part shows the training stage, which has two parallel tracks. The main base model is refined through stages like supervised fine-tuning, or SFT, which is where the model is further trained on a smaller, curated dataset, and then aligned with human preferences. In parallel, a diffusion refiner is trained to upscale and enhance the video. The bottom part then shows the inference stage, how a user's prompt is optimized and fed through the trained model to generate the final, high-resolution output. So to wrap things up, Seedance 1.0 really shows how combining several smart ideas leads to a breakthrough. It all starts with that incredibly well-prepared data and a clever architecture that handles what's in a scene separately from how it moves. Then, the model is made much faster through a process called distillation, which is basically like teaching a smaller, quicker model to act just like the big, powerful original. The result is a model that's a leader in both quality and speed. That's all for today's AI Research Roundup. Thanks for tuning in.